Imagine for a second that you are brushing away centuries of damp soil and tree roots in the dense, incredibly humid jungle of Guatemala.
Oh, and it is humid, like overwhelmingly humid.
Right, exactly. So you're digging through all that and you uncover a wall, just an interior wall of a small buried room that has been completely sealed off from the world for over 1,200 years.
A literal time capsule.
Yeah, a time capsule. But on this wall, faintly visible through the dirt, you don't find, a grand proclamation of a king conquering a rival city.
Right, or a stylized depiction of gods demanding tribute, which is usually what you'd expect.
Exactly. Instead, you find a math equation.
Yeah?
Like a messy, overlapping, heavily revised series of calculations scratched out in black paint. And this specific math equation, well, it fundamentally changes the history of science.
It really does. It rewrites the whole textbook.
It does. So today we are heading into the ruins of an 8th century Maya site called Zoltan. And we are basically opening the door to an ancient, top-secret skunkworks lab.
I mean, the sheer improbability of finding this space intact is just staggering. It's wild. Because, we are conditioned by archaeology to view ancient societies through their monumental architecture.
Right, the big stuff.
Exactly. The grand pyramids, the polished stelae, all those finished products. Those monuments are meant for public consumption. They're PR.
Yeah, they're the billboard.
But what was discovered at Zoltan, it's the backstage area, this is the room where the intellectual elite struggled with the friction of celestial mechanics.
The messy part of science.
Yes. They were calculating the mathematical secrets of the universe on a plaster chalkboard long before presenting those secrets to the public as this, divine inevitability.
And to get into all of this, our stack of sources for this deep dive centers on a massive breakthrough published in the peer-reviewed journal Antiquity.
A fantastic paper.
It really is. The paper is titled The Identification and Work of an 8th Century Maya Mathematician, and the research team, Franco D. Rossi from MIT, David Stuart from the University of Texas at Austin, and Heather Hurst from Skidmore College, they have provided us with so much.
Not just the textual analysis either.
Right. They gave us the accompanying multispectral imagery that they used to pull these literally invisible numbers out of the dark.
Which is a whole sci-fi journey in itself.
No, we are definitely getting into the tech. We are also looking at the broader archaeological data from the San Bartolo Zoltan project. So our mission today is to meet the very first named Maya mathematician and astronomer.
The first one.
The very first. We're going to deconstruct this breathtakingly complex 2,920-day astronomical formula and figure out how the rough drafts scribbled in this hidden workspace actively engineered the political supremacy of Maya kings.
The history of science is just overwhelmingly populated by named individuals from the old world.
Oh, absolutely.
When we consider early naked eye astronomy and complex mathematical modeling, the names Ptolemy, Pythagoras, or Aryabhata immediately surface.
We all learned those names in school.
Right. We track the evolution of thought through specific individual geniuses in ancient Greece, China, India, Iraq. But the ancient Americas, well, they've historically been treated quite differently.
Yeah, they get lumped together.
Exactly. The Maya are universally acknowledged as some of the most sophisticated naked eye astronomers in human history.
Unbelievably accurate.
Unbelievably. Yet their achievements have mostly been relegated to this collective, anonymous, cultural monolith. It's just something the Maya did.
As if the entire civilization just woke up one day and agreed on the math.
Right, rather than recognizing individual brilliance. But this discovery dismantles that monolith entirely.
We finally have a name, but before we get to the name, to really understand the mind of this mathematician, we have to look closely at the physical environment where he worked.
Setting the scene is crucial here.
Yeah. Let's head to structure 10K2. It's 2010. The excavation at Zoltan reveals a structure that, well, it actively defies the typical grandiosity of Maya civic centers.
It is not a grand temple.
Not at all. It's a small masonry building. It features a single southern doorway, and a really large bench dominates the northern half of the room.
And when you say small, I mean it is claustrophobic.
Yeah, intimate and just entirely functional.
Because the architecture dictates the behavior, right?
Yeah.
You not build a room this small if you intend to host an audience.
You literally couldn't fit an audience in there.
No, you couldn't. The bench takes up so much floor space that it essentially functions as a large elevated work table or maybe a communal seating area for a very, very small group.
Like a modern conference room.
Exactly. The environment is designed for intense, focused collaboration. But the walls of this room, They elevate this space from a simple workshop to an elite intellectual sanctuary.
Because of the art.
Right, the interior is covered in these murals depicting men of various ages. Some are kneeling, some are seated in positions of authority.
And the painted texts specifically label these individuals, right?
They do. They label them with the title Taj, which translates to obsidians.
Obsidians, which sounds so incredibly cool, but they aren't like warriors or priests in the traditional sense, are they?
Not exactly, no. The iconography and the context point to a highly specialized order of scholars or scribes.
The math nerds.
The elite math nerds, yes.
Yeah.
And the murals explicitly show a hierarchy. You have these older, established Taj interacting with younger ones, physically illustrating a system of mentorship.
So it's a master-apprentice dynamic.
Precisely. It is unfolding right on the walls of this training center.
And presiding over this entire scene, painted on the north wall, is the 8th century ruler of Zoltan Yaxuan-Chenkinich.
Yes. And the depiction of Yaxuan-Chenkinich is just loaded with theological and political weight. He is not painted in standard courtly attire.
He's dressed up.
Very specifically dressed up. He is seated in a niche, adorned as a maze-wind deity with a scorpion tail.
Okay, maze-wind deity with a scorpion tail. That is quite the title.
It is an intense visual, and the iconography blends agricultural fertility, that's the maze, with the destructive and chaotic force of the wind.
Oh, interesting.
And then it's all anchored by the venomous power of the scorpion. So by placing the king in this highly specific, terrifyingly powerful divine aspect overlooking the Taj.
He's basically saying, I own this.
Exactly. The mural signals that the mathematics and the codex production happening in this room are directly sanctioned by and feeding into the highest echelons of divine royal authority.
Okay, so this room operated during the Classic period, which is roughly 250 to 900 CE. But the reason we can even see Yaxuan-Chenkinich and his obsidians today, it actually comes down to a structural decision made by the residents of Zoltan in the mid to late 8th century.
A very lucky structural decision for us.
Incredibly lucky, because they didn't demolish structure 10K2 when they outgrew it or when regimes changed. They deliberately filled the entire room with mud, stone, and debris.
They packed it full.
Right to the ceiling. Packed it tight to serve as the foundation for a newer, raised building on top of it.
Which is wild because that packing material acted as a perfect protective matrix.
It stopped the decay.
Yeah, by entirely displacing the air and creating a solid block of earth and stone right against the painted plaster, they inadvertently halted certain types of environmental degradation. They created a time capsule.
Because usually if you find a stela out in plaza, it's wrecked.
Oh, completely. When you encounter a formal Maya stela out in the plaza, it has been subjected to a millennium of acid rain, wind erosion, biological growth, you name it.
But the interior of 10K2 was spared the worst of that surface level weathering.
Exactly. It locked its final moments into the archaeological record.
And the final moments of this room are where the real story lies. Because the formal murals of the king and the obsidians are stunning, obviously, but they aren't the actual breakthrough.
No, they are just the canvas.
Right. The breakthrough is what is painted over them. Over in the northeast interior corner, and stretching across the east interior wall, the scholars were actually using the mural itself as a scratch pad.
Disrespecting the beautiful art for the sake of math.
Completely. The archaeologists identified around 52 painted microtexts, these tiny, rapidly executed hieroglyphs just clustered together.
So tiny.
And they were painted directly over the formal figures. Sometimes they'd even slap on fresh patches of lime plaster, specifically to blank out a section of the mural so they had room to write.
The juxtaposition is brilliant. I mean, it really speaks to the utilitarian nature of the room. A formal, beautiful mural was deemed, well, less important than the immediate need to calculate a planetary cycle.
They needed to do the math right now.
Right. They would slap a patch of fresh stucco over a beautifully painted obsidian's face just to have a clean surface to carry a 1 over in a complex mathematical formula.
That is amazing.
It reveals this incredibly fast-paced, iterative intellectual environment. Because the formal monuments tell us that the Maya aligned their royal inaugurations with the position of Venus. But structure 10K2 is where the obsidians actually did the grueling math to figure out when that alignment would occur.
And finding the everyday functional math of the Maya is almost impossibly rare, isn't it?
Oh, we almost never see it.
Because we know they wrote extensively on bark paper, creating these massive libraries of codices. But, bark paper rapidly disintegrates in the jungle humidity.
It turns into mush.
Yeah, if it wasn't carved into a limestone monument, it largely vanished. So these plaster microtexts survive as like a phantom echo of those lost libraries.
A very fragile echo.
Very fragile, because just because they survived being buried in mud doesn't mean they were easy to read. In fact, getting the text off the wall required a technological feat that honestly borders on science fiction.
It really does. The physical reality of structure 10K2 upon excavation was an absolute nightmare for preservationists.
Because of the water, right?
Yeah. Yes, the deliberate filling protected it from wind, but the room sits precariously close to the modern ground level. So for 12 centuries, the lime plaster has been subjected to relentless water filtration.
Every time it rained.
Exactly. Every single monsoon season, water percolated down through the soil, carrying dissolved minerals and acidic compounds, washing over the painted surfaces. And tree roots, seeking moisture, they spiderwebbed across the walls, chemically altering the plaster they clung to.
So the preservation of the microtext was just agonizingly uneven.
A total mess.
Because you were dealing with carbon-based black paint applied to calcium carbonate, which is lime plaster. And over time, the plaster becomes incredibly friable.
It turns chalky and crumbly.
Right. And the black pigment fades, it diffuses, and gets covered by this mottled layer of dirt and mineral deposits that visually blend perfectly with the ancient paint.
You can't tell what is dirt and what is paint.
Yeah. To the naked eye, looking at the east wall was like looking at a dirty, water-stained piece of drywall. You might see a faint, dark smudge, but you couldn't distinguish a human-made hieroglyph from a patch of mold or a mineral stain.
And, the immediate instinct when uncovering a dirty artifact is to clean it.
Naturally. Get a brush, wipe it off.
But the physical chemistry of the wall made that impossible. The carbon black pigment is bound so weakly to that friable surface. If a conservator were to take even the most delicate sable hair brush and apply the gentlest mechanical friction to remove the dirt, the carbon pigment would simply flake off right with it.
Oh, that's terrifying.
It is. The human-made marks are functionally suspended within the layer of decay. To clean the wall is to destroy the text.
So you have a priceless mathematical formula slowly dissolving in front of you, and touching it basically erases it.
So what do you do?
Right. How do you save it? Well, the research team had to bring the laboratory into the jungle trench. They couldn't rely on standard photography.
No, standard cameras wouldn't cut it.
So they brought in these 400 DPI flatbed scanners, rigging them up in this cramped, humid, subterranean environment, and began systematically scanning the fragile surface inch by excruciating inch.
Which must have taken forever.
And they also employed raking light, which is where they move a lamp at extreme angles across the wall to catch the microscopic topographical variations of the painted lines.
To see the actual bumps and grooves.
Yeah, producing traditional scale drawings right there in the field.
The flatbed scanners provided the high-resolution baseline, sure, but the true analytical power came from capturing the wall outside the visible light spectrum.
This is the sci-fi part.
This is it. The researchers utilized near-infrared imaging, specifically targeting the 690 to 730 nanometer wavelength range.
And why that specific range?
Well, the physics of near-infrared light allow it to bypass the topmost layers of dirt, biological growth, and certain mineral efflorescence that opaque visible light.
Because the materials react differently to the light.
Exactly. The calcium carbonate of the plaster and the accumulating dirt, they reflect or scatter the infrared light. But the carbon black paint used by the Maya scribes behaves entirely differently. Carbon is an exceptional absorber of infrared radiation.
It just drinks it in.
Yes. When the scanners hit the wall with near-infrared light, the dirt and plaster bounce it back, but the carbon paint absorbs it. So in the resulting image, the invisible carbon paint suddenly registers as a stark, dark void against the lighter background.
It effectively gives the researchers X-ray vision.
Basically, yes.
Yeah.
Bypassing the decay to reveal the original strokes of the brush.
But even with near-infrared absorptions, some of these microtexts were so thoroughly degraded that the signal was still incredibly weak, right?
Oh, very weak. The carbon had physically diffused over time.
Right. So to solve this, the team ran the multispectral data through a specialized software algorithm known as D-Stretch.
D-Stretch. It's a game changer.
It is. Originally developed for analyzing heavily faded rock art in the American Southwest, D-Stretch relies on a mathematical process called principal component analysis.
Which sounds intimidating, but it's brilliant.
It really is. Instead of just boosting the contrast like, a standard photo editing app on your phone, D-Stretch fundamentally reorganizes how the image data is presented. The paper details how they merged the blue pixels of the CRGB color space over the YBK color space.
Which, in plain English.
Right. In plain English, what the algorithm is doing is taking the faint, almost statistically insignificant color variations between the diffused carbon paint and the stained plaster and mathematically forcing those subtle variances apart.
Pushing them to the extremes.
Exactly. It maps those tiny differences onto entirely new, high-contrast color palettes.
The software detects a 1% variance in the absorption data that the human eye could literally never perceive.
Wow.
And it assigns the dark pixels a neon red color and the background pixels a bright yellow.
So it just pops right off the screen.
It does. It artificially isolates the human-made geometry from the random noise of the wall's decay.
That is so smart.
And through this intense, non-invasive digital excavation, a cluster of 11 specific hieroglyphs emerged from the center of the east wall, forming a clear, inverted L shape.
And this is what the researchers designated as Text 19.
Text 19.
And Text 19 pulls us directly out of the physical dirt and drops us straight into the dizzying, abstract realm of Maya computational astronomy.
It's quite a shift.
Because when the researchers translated these 11 glyphs, they didn't find a simple date or a historical name. They found an overarching calculation governing a specific, massive cycle of time. Exactly 2,920 days.
2,920. The number 2920 is the foundational architecture of the mathematics we are about to discuss.
It's the key to everything.
It is. To grasp the genius of Text 19, we really have to understand the friction inherent in Maya timekeeping. The Maya utilized multiple concurrent calendars.
Right. They had several running at once.
The two most prominent were the Hab, which is the 365-day solar year, and the Sulcan, which is the 260-day sacred ritual calendar.
Got it.
But they were also master naked-eye astronomers tracking planetary movements with terrifying precision. They calculated the synodic period of Venus, which is the time it takes for Venus to return to the same position in the sky relative to the sun in 584 days.
Okay, so the friction comes from trying to align these wildly different cycles. You have a 365-day solar year and a 584-day Venus cycle, and they are constantly out of phase.
Always slipping past each other.
But the Maya were obsessed with finding the grand symmetries of the cosmos, the moments when the gears of the universe locked into place.
And they found them.
They did. If you multiply the 365-day solar year by 8, you get 2,920 days. If you multiply the 584-day Venus cycle by 5, you also arrive at 2,920 days.
It is the lowest common multiple. Every 2,920 days, precisely 8 solar years and 5 Venus cycles synchronize perfectly.
They lock together.
Yes. The Sun and Venus return to the exact same relative starting positions. This cycle was a known quantity in the Maya world. We see it recorded in massive stone monuments and in the post-classic Dresden Codex, charting the mythological journeys and manifestations of Venus deities.
So the 2,920-day cycle is the standard baseline.
Exactly. It's established knowledge, but what the mathematician in Structure 10K2 is doing with Text 19 is taking this monolithic cycle and dissecting it from the inside out.
Right. They aren't just stating the total. They are charting a completely novel path to get there. Text 19 consists of 5 specific calendar dates, separated by 4 highly deliberate mathematical intervals.
It's like a map.
It is. The scribe takes the massive 2,920-day block and chops it into smaller, deeply meaningful chunks, escalating in size. Let's trace the physical math painted on the wall, step by step.
Okay, let's do the math. The sequence begins with a starting date anchored in the calendar round. The researchers reconstructed this initial point as the date 4 Akbal.
4 Akbal.
Yes, this is ground zero for the equation.
From 4 Akbal, the text dictates the first interval. The mathematician adds 1 uinal. Now, the uinal is the standard 20-day month in the Maya calendrical system.
So we're just adding 20 days.
Yep. You add 20 days to 4 Akbal, and you arrive at the second step. The date 11 Akbal 6-packs.
Okay, so the first jump is a modest 20 days. But from 11 Akbal 6-packs, the formula aggressively expands. The next interval instructs the reader to add 13 unals.
And 13 20-day months equals exactly 260 days.
Yes. The mathematician has explicitly embedded the entire Sulcan ritual calendar into the progression.
Which is wild because the friction between the 365-day solar calendar and the 260-day ritual calendar was like the heartbeat of Maya daily life.
It governed everything.
It really did. So by dropping a full 260-day cycle right into the middle of a Venus solar equation, the scribe is forcing the ritual calendar to mathematically mesh with the planetary movements.
They are linking human ritual to the sky.
You add those 260 days and you arrive at step 3, 3, the date 1, Zach.
So we've added 20 days, then 260 days. The sequence is escalating. And from 1 Zach, the third interval introduces a staggering conceptual leap.
This is the mind-blowing part.
It really is. The text dictates an addition of 1,560 days. This is pure observational astronomy forcing its way into the calendrical structure. 1560 is exactly 2 synodic periods of the planet Mars.
Mars, just out of nowhere.
Yes, Mars. The Maya calculated the Mars cycle, tracking its complex retrograde motions across the night sky, without telescopes, mind you, at 780 days. 2 of those cycles equals 1,560 days.
This is where the sheer brilliance of the mind at work becomes undeniable. Within an overarching formula designed to synchronize Venus and the Sun, the mathematician casually threads a massive double cycle of Mars through the center of the equation.
This flexes their astronomical muscle.
Right. You add the 1560-day Mars interval to your running total, and you land on step 4. The date 1 Pax.
And only 1 interval remains to reach the grand total. From 1 Pax, the final painted instruction is to add 3 tons. A ton is a 360-day period, which is the core computational unit of the long count calendar.
And 3 tons equals 1080 days.
Exactly.
So you add that final 1080 days, and you hit the terminus of the equation. Step 5, the date 6, 1.
The finish line.
The finish line. And when you sum the carefully chosen intervals, the 20-day month, the 260-day ritual cycle, the 1560-day dual Mars cycle, and the 1080-day ton cycle, they lock together flawlessly to total exactly 20,920 days.
The perfect Venus-solar synchronization is achieved.
It is so satisfying. But the why is just as important as the what, right? Like, why structure the math this way?
Exactly. Look at the numerical progression. You go 20, 260, 1560, 1080. It's an escalating, almost Fibonacci-like sequence that purposefully weaves disparate cosmic phenomena together.
It's poetry with numbers.
Yes. The scribe took a rigid, well-known block of time and demonstrated how the cycles of the ritual calendar, the solar calendar, Mars and Venus, all mathematically nest within one another.
You know, the best way to visualize what Text 19 represents is to think of jazz music.
Oh, I like that analogy.
Right. The 29-20-day Venus-solar synchronization is a classic foundational chord progression. Every trained musician knows it. Every Maya astronomer knows it.
That's the baseline.
But what this mathematician did on the plaster wall of 10K2 is perform a breathtakingly complex, original jazz solo over that standard beat. The baseline remains the same, but the way they dance between the retrograde motion of Mars, the sacred 260-day count, and the solar year to get to the end of the measure, it's a completely original intellectual riff.
The Antiquity paper actually frames this perfectly. They call it a creative expression of mathematical thought.
Creative expression.
Yeah, this is not an accountant logging grain yields. This is a theoretical physicist finding hidden, elegant symmetries in the mechanics of the solar system. They are playfully, yet with absolute rigorous precision, demonstrating that the disparate gears of the cosmos are intricately connected.
And this specific internal arrangement of intervals, we've never seen it anywhere else, have we?
No, this specific arrangement has never been seen in any other Maya text. It is a unique masterpiece of indigenous science.
And if you are the mind that constructs a mathematical jazz solo of that magnitude, if you discover a new, elegant way to force Mars and Venus to mathematically align with the sacred calendar, you are going to want credit for it.
You definitely want your name on that.
The mathematical brilliance of Text 19 is matched only by the final strokes of the brush at the bottom of the column.
Because the sequence of 11 glyphs concludes with 2 symbols at positions C8 and C9. And unlike the previous 9 glyphs, these final 2 are entirely non-calendrical. They contain no numerical coefficients.
They're words.
They're words. The researchers translated the glyph at C8 as Chehina, which is a quotative particle deeply embedded in Maya linguistic structure. It translates roughly to so says or thus speaks.
So says. It's a dramatic, definitive statement of authorship, and it points directly to the final glyph, C9, which spells out a specific personal name. Sak Tahn Waax. Sak Tahn Waax.
Sak Tahn Waax.
Translated into English, the name is white-chested fox.
So says white-chested fox. The mathematician signed his work. The historical and anthropological weight of those 2 glyphs is, well, it's a paradigm shift.
It changes everything.
We have observed signatures in Maya art before. A master sculptor carving a royal monument or a master painter decorating an elite ceramic vessel would occasionally embed their signature, claiming the physical artifact.
Like saying, I made this pot.
Exactly. But this is the absolute first time in the archaeological record that a classic Maya mathematician or astronomer has explicitly signed their computational work.
They aren't claiming a physical object. They're claiming ownership of an abstract intellectual concept.
Intellectual property.
But wait, I have to look at this skeptically for a moment, if you don't mind.
Please do.
Given that this room is a training center filled with obsidians learning from mentors, how do we know Sak Tahn Waax actually painted this? What if Sak Tahn Waax is just a famous, long-dead astronomer and a young student painted text 19, essentially citing his sources, like a modern physics student writing, "So says Einstein," next to EMC2 on a whiteboard?
The paper addresses this exact ambiguity, and it's a really vital distinction to explore. We cannot definitively prove that the physical hand holding the brush and applying the carbon black paint belonged to the living man named Sak Tahn Waax.
Okay, so it could be a student.
It could be his direct signature upon completing the calculation, or it could be a devoted student attributing the genius of the formula to their mentor. But critically, the historical magnitude remains identical in either scenario.
Because either way, the idea belongs to him.
Precisely. The text explicitly credits an original mathematical idea to a specific, named indigenous Maya thinker.
The culture recognized that this specific arrangement of numbers belonged to the mind of white-chested Fox.
Exactly. It elevates him into the global pantheon of named historical scientists. When we teach the history of astronomy, we naturally cite the named scholars of ancient Greece, or the mathematicians of the Islamic Golden Age.
Of course we do.
The Maya have been denied that specificity. But the signature of Sak Tahn Waax shatters the illusion of the anonymous Maya collective, proving that their staggering cosmic architecture was built on the rigorous, individual genius of scholars claiming their intellectual property.
Okay, so we have the genius and we have the math. Now we have to figure out how this specific formula painted in a hidden room actually dictated the reality of millions of people.
It's all about application.
Right. How does the esoteric math of white-chested Fox translate into the hard political power of the Zoltan kings? To answer that, we have to look at the physical tools left behind in Structure 10K2.
Because the archaeologists didn't just find painted walls. They found the artifacts of industry.
It was a workshop.
Scattered in the room were specialized tools, specifically bark beaters used for the maceration of fig tree bark. These are the instruments of papermaking. Structure 10K2 was an active, high-volume workshop for the manufacture of codices.
And the significance of this cannot be overstated. Due to the catastrophic destruction of Maya texts by Spanish colonizers and, of course, the unforgiving climate, only 4 pre-colonial Maya codices survive in the entire world today.
Just 4.
The Dresden, Madrid, Paris, and Grolier codices. And all of those date to centuries after the Classic period.
They're post-classic.
Right. We have never had a physical archaeological context for how these books were created during the height of Maya civilization. Structure 10K2 is the missing link.
And the surviving post-classic codices are filled with Venus and Mars tables remarkably similar in theme to text 19.
Okay.
What we are seeing in 10K2 is the raw developmental stage of that knowledge.
The brainstorming phase.
Yes. The layers of plaster on the walls, constantly erased and painted over, show a process of hypothesizing, calculating, and correcting. Once the formula like Sak Tahn Waax's 2920-day masterpiece was perfected on the plaster chalkboard, it was transferred onto the freshly pounded bark paper, bound into a codex, and brought before the king.
Because the king is the ultimate consumer of this data. In the classic Maya world, numerology wasn't just an academic pursuit, it was the structural scaffolding of political reality.
It was everything.
The timing of a royal inauguration, the dedication of a temple, the initiation of warfare, none of these decisions were arbitrary. They were all strictly dictated by the celestial mechanics calculated by the Taj.
The rulers utilized this astronomical data to basically weaponize time itself. The calculations were painstakingly derived in the secret, claustrophobic environment of the skunkworks lab.
Out of sight.
But the results were deployed in massive, highly choreographed public spectacles. By aligning a political ascension or a ritual sacrifice with the precise retrograde turn of Mars or the heliacal rising of Venus, the king visually and culturally merged his authority with the inescapable mechanics of the universe.
So the Obsidians are really the ultimate political strategists.
They are the power behind the throne.
Think of them like an elite speechwriting and PR firm working for a modern president, but combined with a team of theoretical physicists.
That is a perfect analogy.
The king stands atop the pyramid, delivers a spectacle, and projects an aura of divine infallibility to the masses. The populace sees a ruler in perfect harmony with the gods, but the illusion is powered by Sak Tahn Waax sitting in a windowless room, grinding through the math, figuring out how to perfectly nest the 260-day ritual cycle into the planetary orbits so the king knows the exact mathematical second to strike.
Knowledge in Zoltan was not passive. It was the ultimate instrument of control. If the Obsidians controlled the calendar, they controlled the agricultural cycles, the economic cycles, and the psychological rhythm of the entire society.
They ran the clock.
Sak Tahn Waax wasn't just observing the sky, he was writing the mathematical script that governed the empire. This discovery forces a profound reevaluation of indigenous science, demanding we recognize the rigorous, iterative labor and the individual intellectual agency that built the Maya civilization.
So let's pull all these threads together. We stepped into a 1,200-year-old time capsule buried under the mud of Guatemala.
An amazing journey.
We watched modern scientists use near-infrared spectroscopy and color space mapping algorithms to pull invisible carbon paint off crumbling plaster.
The stretch algorithm doing its magic.
We deconstructed Text 19, this breathtaking mathematical jazz solo that elegantly nested the cycles of Mars, the ritual calendar, and the solar year inside a 2,920-day Venus synchronization.
A masterpiece of math.
We met Sak Tahn Waax, white-chested fox, the first-named mathematician of the Maya world, who proudly signed his brilliant equation. And we saw how his hidden workspace manufactured the codices that allowed kings to rule by the authority of the stars.
It is a narrative that truly elevates Maya science from an anonymous cultural trait to a dynamic history of individual intellects actively shaping their world.
The implications are just massive, but there is one final, staggering thought I want to leave you with. A thought that isn't explicitly mapped out in the data, but is the inescapable conclusion of everything we've unpacked today.
Oh, I know where you're going with this.
We lament that only 4 Maya codices survived the colonial purges, assuming that the vast library of Maya intellectual history was burned and lost forever.
A seemingly insurmountable erasure of knowledge.
But look at Structure 10K too. It wasn't preserved by a museum. It survived precisely because the Maya themselves meticulously filled it with stone and sealed it beneath the foundation of their own city.
Just normal urban expansion.
Right. So if this one, single room preserved by the mundane act of architectural expansion, yielded the signature of white-chested fox and a revolutionary cosmic equation, what else is down there?
Oh, it gives me chills.
How many more ancient chalkboards covered in the messy, brilliant, rough drafts of other named genius mathematicians are currently sitting perfectly preserved in the unexcavated bedrock of the jungle, quietly waiting for the right technology to look through the plaster?
A civilization's worth of hidden skunk works, silently holding the blueprints of the cosmos.
The work is still out there. We just have to keep digging.